DCS, as its name says, is a decentralized control system, or in other words, is a control method in which we have some independent CPUs. Each CPU is in charge of controlling individual parts of the process, so that if one fails, the other CPUs will continue performing their function without interruption. On the other hand, the name of PLC, or Programmable Logic Controller, does not imply the concept of centralization or non-centralization by itself. What we see in practice is like PLC mostly used for centralized control, meaning that a single PLC or CPU will control the whole process. However, this answer sounds to be correct to some extent, but this is not the whole story. We must be aware of some other major differences between PLC and DCS, such as their hardware and software. The primary goal of the PLC's invention was to replace them with the old control systems, which were entirely made of relays and contactors, or digital signals in other words. DCS, or Distributed Control System, was made a few years later not to replace the PLCs, but to satisfy other needs in the automation industry. Therefore, PLC and DCS have coexisted in the industry for many years in different applications, and they have their significant pros and cons. Although the PLCs became more advanced and sophisticated these days, and are even able to control the PID loops and analog signals, they are more appropriate to be used for discrete processes automation, such as the automobile assembly line, in which there are lots of digital signals and a few analog signals. DCS is more applicable for continuous processes with lots of analog signals and complicated PID control loops, such as processes in a power plant or a refinery. In batch or hybrid processes automation, like some steel-producing industries, in which we have to use DCS and PLC together, there would be some overlaps in their functions. Meaning that we may use the PLCs to process a limited number of analog signals and PID loops, in addition to processing the digital or discrete signals. Consider that, as the number of control loops and analog signals assigned to a PLC increases, the control reliability of the process decreases dramatically, because if the PLC fails, then all the loops assigned to that will be out of control and the whole process fails consequently. On the other hand, if we use the DCS to process discrete signals, since the reaction time or scan cycle time of the DCS is fairly high in comparison with the PLC, the real-time controlling of the process would not be possible. The high reaction time or scan cycle time of the DCS is due to its heavy processing duties. For example, the DCS is using high-level programming languages, such as CFC or continuous function chart, to issue some extended and very useful programming, monitoring, and engineering facilities, like lots of predefined functions. These high-level languages will generate lots of codes after getting compiled, and put lots of burden on the CPU. As a result, the response of the system to the important inputs will not be fast enough. On the contrary, the popular low-level PLC programming languages, such as ladder logic, function block diagram, and particularly STL or structured text language, are closer to the machine language. And therefore, the generated codes are remarkably fewer than the DCS programming languages. It's the reason that the PLC is used for the emergency systems. So to take advantage of the languages like CFC, the hardware of the DCS should be more powerful than a PLC system. However, with today's advancements in technology, the hardware of the DCS and PLC are more close to each other. Sometimes, it's not possible to judge whether a control system is DCS or PLC only by looking at its electrical control panel. Even in some cases, PLC control systems employ the same CPU as the ones commonly used in decentralized control systems. Finally, it is the DCS and PLC monitoring system differences. In DCS, there is an integrated software package in which there is a fairly complete set of monitoring facilities. By calling the control functions into the programming environment, their corresponding graphical objects will automatically be added to the HMI pages with their addresses. In this way, we'll save some precious time. In PLC systems, however, usually there is no relationship between the programming and the monitoring environments, and they need their own time to be created and developed. As a last point, the decentralized control systems are more reliable in comparison with the PLC control systems, not just for being decentralized, but for being usually redundant in different levels. from CPUs and power supplies to servers, network switches, and network cables. There are lots of benefits in using both the DCS and PLC. As the DCS response time is more than the PLC, the DCS is better to be used for processes with more analog signals and PID loops, whereas the PLC systems are better for processes with more discrete and less analog signals. In DCS, we can benefit from numerous predefined functions and function blocks and its high-level programming languages. But in PLCs, we often have to write and define the functions by ourselves. We also talked about the benefits of the DCS in designing the monitoring system. The network architecture of the DCS is very easier to implement, using its integrated software and hardware package. However, DCS software and hardware packages cost a lot more than PLC equivalents.